Hey everybody, this is Remy, and this video covers the Math 124 note outline for Chapter 3, Section 2, which is quadratic equations, functions, zeros, and models. So a quadratic equation is an equation of the form ax squared plus bx plus c equals 0, where a, b, and c are real numbers and a does not equal 0. And we have to have a not equal to 0 because if it were 0, then this first term would disappear and we'd have just a linear equation. And then a quadratic function is a function f of the form f of x equals ax squared plus bx plus c, where a, b, and c are real numbers and a does not equal 0. So I'm going to review techniques to solving quadratic equations, which is very similar to what was done in the just-in-time review, especially when we talk about the second technique, which is factoring. So first, the method I call, quote, directly, which is basically just isolating the variable. And then second will be factoring along with the zero product property. And then third and fourth are completing the square and quadratic formula. And the order that I've listed them in is also usually the order that I try them in. If I have a quadratic that I need to solve first, I'll do it directly if possible. If not, I try factoring with the ZPP. And if that won't work, if the AC method won't work, for example, then I'll just use one of these two, just depending on what the numbers are. So first, solving what I call directly. So basically we're just going to try to isolate that variable. And solve means what does the variable have to equal to make the entire equation true. So here, if I wanted to get this x by itself, what do we do first to both sides? We want to get rid of the minus 7, so we'd add 7 to get that. And then we have x squared, and we have to say, how do you get rid of x, or how do you get rid of the square part? To undo a square, you have to take the square root of both sides of the equation. You'd get that, but whenever you take the square root of two sides of an equation, you have to put something here in front of the root, and that's plus and minus. And then we've reached our goal. We isolated x. We got x by itself, and those would be our solutions. Positive root 7 and negative root 7. Two solutions to this equation that when you plug them back in, it will make the equation true. And then this one over here, part B, is a little bit more complicated, but our goal is still the same. We need to figure out what G is. So the first thing I do, or the first thing I see that I can get rid of, is this 3. Well, this is 3 times this, so to undo that, I need to divide everything by 3. So I divide the left side by 3, get that. 36 divided by 3 is 12. And now I'm in a similar position to this example, something squared. Something squared. To undo that, we take the square root of both sides, and again we need to put plus and minus root of that side of the equation. And then in this case, root 12 can be simplified because 12 is 4 times 3. So root 4 times 3, I can pull the root 4 out, which is 2, and then leave the root 3 inside. And then we're almost done because we still haven't reached our goal, get G by itself. So this is a plus 2, so to get rid of it, we'll subtract 2 from both sides. And If you notice, I put the -2 in front of this instead of out here, which is just more standard math notation. Usually when you have a plus and minus, you put the number in front of it instead of at the end. So again, we got two solutions, -2 plus 2 root 3, and also -2 minus 2 root 3. If you plug each of those back in to the original for g, it does turn out that it will make this equation true. Okay. Alright, so now before we get into the second technique, we're going to kind of review ZPP, the zero product property. So, if I told you that I was thinking of two numbers, and then I multiplied the two numbers, and it equals 0, what do you know about those two numbers? Well, it must be true that one of the numbers had to be 0 in order to get that product of 0. And so that's what this zero product property is based on. So if you have two numbers that multiply to 0, that's true if and only if either A is 0 or B is 0. That's zero product property, and so what you have to use this property is that you have to have a product, meaning multiplication, and then that product has to equal the number 0, hence the name, zero product property. So that's what we'll use in these next examples before we get into technique 2. So right now we're just practicing zero product property. So in this first example, we do have a product, and the product does equal 0. So that means we can use the zero product property. So we have a number, this is some number, times some other number equals 0. So by the zero product property, either this first number has to equal 0, or this second number has to equal 0. And now we've reduced it to really simple equations that we know how to solve. We want to get x by itself, so x equals 3. Add 3 to both sides. And this one will give us y equals -5. So these would be two solutions to this equation, because when you plug each of them back in, it makes the equation true. Okay, now this next one, it does equal 0, but this is not a product, right? Plus is a sum. So we can't use this yet, but when you see something like this, you think about, well, what else could we do? Well, what I see is that they both have a w in common, so that's their GCF. Factor the GCF out to the front. So this is equivalent, this left side is equivalent to this, and now do we have a product? Something times something. We do, equals 0, so by the zero product property, either this first one has to equal 0, the first factor, or the second one equals 0. And if, for this one, it's done. W equals 0, isolated W. For this one, W would equal what? -2. And then these are both solutions because when you plug them back into the original equation, it does make it true. Plug each of them back in and you can check. So that's the zero product property. And then we will move on to actually that applying that second technique, which is solving by factoring, and also the zero product property. So the goal is to factor first, because factoring will give us a product, something times something. That's what factoring does. And then we want, if we want to use a zero product property, we have to make sure it's going to equal 0. So for this one, factoring we're trying to factor and create a product out of this, what I think of is I see that we have 4 terms here, and a technique we've reviewed in the past with 4 terms is factor by grouping. And it's called factor by grouping because you kind of imagine these two grouped together and you imagine these two grouped together, but you don't actually put parentheses or anything like that around them. You're just kind of thinking of these two being paired together, thinking of these two being paired together. And then these two, you can factor out a GCF. So what do these two have in common that you could factor out from each one? Well, they have a 3, they're both divisible by 3, and they're also both divisible by a y. So 3y, and then you put parentheses times, well, if we factor a 3y out of each, from this one, what will be left over? A y. And then we have a minus here. And then this one, if we take 15y divided by 3y, we're just left with 5. And close it off. And then you decide, what do these two have in common? The only factor they have in common is a 4. But you cannot just write 4 here. You must put a symbol in front of the 4, either a plus or a minus. In this case, we're going to write a plus, we're going to factor a positive 4 out. And the reason for that is if you don't write it, what symbol does it really have there if you don't write it? It would be multiplication, but we're not multiplying these two. We are adding the 2. Or maybe there would be subtraction. But anyway, we really need a symbol there. And then we're factoring a 4 out. And what would be left from this term? We'd be left with a y. We're factoring out a positive 4, so we'd be left with minus 5 inside. Equals 0. Now, at this point in the factor by grouping technique, you look at these two parts, which I usually call, quote, leftover parts. And if you are doing the problem correctly, these should come out to be the same. And they are, which is good, because that means that they are a common factor that this term and this term both have in common. Therefore, you can factor that out to the front, like we usually do, and then write the leftover parts. Well, from this part, if we take a y minus 5 out, we're left with 3y. And from this other term, if we take the y minus 5 out, we're left with that plus 4 equals 0. Okay, and now we have a product that equals 0, so now we can use a zero product property. Either y minus 5 equals 0, or the other factor, y plus 3y plus 4 equals 0. Solve each one. This one will give us y equals 5. This one, we'd have to subtract the 4 from both sides, and then after that, we would have to divide by 3. So we'll end up with y equals negative 4/3. And if you plug both those in, they will both make the equation true. Okay. So those would be our solutions. And now the next problem is worded a little bit differently. This problem says find the zeros of, oh, there should be an F here, sorry, there's a typo, of f of x equals this. Well, if you remember back when we talked about zeros, a zero is graphically, say we have a graph like that, this would be a 0, this would be a 0, and this would be a 0. So these are x-intercepts, or zeros. Therefore, the y value for all of these is what? If you look at these 3 points, the y value is always 0, and we call that f of x. We call y f of x. So basically, anytime you want to find a 0 of a function, you need to set the function equal to 0. So we'll write x cubed minus 8x squared minus 9x has to equal 0. Now, our technique that we're trying to do is factoring. So, first thing with factoring, you always want to check for a GCF. Do these three things have something in common? These three terms. They do. They all have an x, so we'll factor that out. We'd be left with x squared minus 8x minus 9 equals 0. And then we say, okay, can this part be factored anymore? And since a is 1, we would try the basic way of factoring, which is trying to figure out two numbers that multiply to negative 9, and then they'd have to add to negative 8. Well, those numbers would be what? They should be minus 9 and plus 1, because those multiply to negative 9 and they sum to negative 8. And now we have a product, something times something times something equals 0. This is fully factored, so we can now set each of those factors equal to 0, and gives us one answer, two answers, three answers, three solutions. So these would all be the zeros of the function. So this means if you plug each of these in, if you find f of 0, f of 9, and f of negative 1, it's going to make the function equal 0. Okay, so part B, we were finding zeros, which led us to set the equation equal to 0, and then we could use that second technique for the quadratic that showed up here. Now this next one, part C, if we're trying to use this technique with factoring and zero product property, that means that we have to have it equal 0. So first thing I'm going to do is add this 4 to both sides, so that way we have that expression equals 0. And then the next thing is that this looks similar to the typical quadratic equation, but not entirely. So to make it quadratic with a power highest degree 2, what I'm going to do is look at this term here, and I'm going to say, let's let u equal that x squared. I'm going to make u the variable instead. And then also what will happen if I do that, what would u squared be? If u equals x squared and then we square both sides, we'd get u squared equals x to the 4th, which is this part. So now we're just going to substitute. So x to the 4th is u squared minus 5x squared is u plus 4 equals 0. So we've just reduced it to a simpler quadratic equation. So the u is just kind of being a placeholder right now for x squared. And then this is a quadratic, a is 1, so we can try to factor it by asking ourselves, well, what multiplies to positive 4 and sums to negative 5? Well, that would be the numbers negative 1 and negative 4. And now we can take this in a couple different ways, but what I'm going to do now is, now that we've done the factoring, I'm going to go back and replace u with x squared. So don't forget to do that, because the original variable was x, not u. And now alarm bell should be going off when you see this, something squared minus 1, something squared minus 4. These are special factoring expressions. These are difference of squares. So you can factor even more if you like. That's one option. Or what I'm going to do is, since we have a product that equals 0, I'm going to set each one equal to 0. Use the zero product property. And now these are two quadratic equations that I could just solve using my directly technique. So I'm just going to get x by itself now. I'll add 1 here. Get rid of the squared by taking the square root of both sides, and I got to put plus and minus the square root of 1. But that's just 1, so I'll just write it like that. And then this one, I will add the 4 over, so x squared equals 4. And then, again, take the square root of both sides, so I have to put plus and minus, but the square root of 4 is 2. And those would be our solutions to the original equation. We actually have 4 solutions this time. Plus 1, minus 1, plus 2, minus 2. And maybe you'll notice also that we have 4 solutions and the degree was 4 originally. Or in the previous one, we had 3 solutions and the degree is 3. And here we had 2 solutions and the degree was 2. So that is what will always happen. You'll always have the same amount of solutions as the degree of the exponent. They might not all be real solutions, but that's generally what is going to happen. Alright, so C, we did a substitution, a U substitution. Part D also doesn't really look like the standard ax squared plus bx plus c, so we're going to again kind of force it to look that way. So I know I want something squared at the beginning and then something to just the first power. Well, I have a 2 and I have a 1. But the problem is that it's over 3. But what I can do to fix that is I can say that t raised to the 2/3 is really t to the 1/3 raised to the second power minus 2t to the 1/3 minus 3 equals 0. Because 1/3 times 2, remember when you have an exponent raised to another exponent, you multiply the exponents. So this is t to the 2/3, which we originally started with, minus 2t to the 1/3, minus 3 equals 0. And now this time I'm going to say let u equal that part, the t to the 1/3. Well, if u equals t to the 1/3, then we can just rewrite this. T to the 1/3 is u, and then we can square it. So we have u squared minus 2, this was u, minus 3 equals 0. So again, just like in part C, we reduced it to a simpler quadratic equation. And a is 1, so we don't have to do that full AC method, we can just try to factor it normally. And two numbers that multiply to -3 and sum to -2 would be minus 3 and plus 1. Okay. And now let's go back and replace the u with t to the 1/3. Don't forget to do that. Always replace with the original substitution that you made. So now we have two factors that multiply to 0. So we'll use the zero product property. So this means that over here, t to the 1/3 minus 3 equals 0, or t to the 1/3 plus 1 equals 0. Okay, and then again our goal is to just isolate the variable, so let's add the 3 over in this equation. And now we need to get rid of this 1/3 somehow. But this is in the exponent. So we have to think, what's the opposite of raising something to the 3rd power? Or what can we do to this that would make this 1/3 become 1? Because we just want t to the 1 equals something. Well, what we can do is raise it to the third power. And if we raise this side to the third power, we have to raise that side to the third power. Because we have exponent to an exponent, so we have to multiply these exponents, and 1/3 times 3 is 1. So we get t to the 1 equals 3 cubed, which is 27. So t equals 27. And then on this side, for this equation, start by subtracting 1, and then we'll do the same thing to get rid of the 1/3. Raise both sides to the power 3. This will become t, and -1 cubed is -1. And those would be our solutions to that problem. Okay, so that was technique 2, where we decided to try to factor and make sure that equals 0. And so really you need to make sure it equals 0 first and then begin your factoring. Then once it is fully factored, set each factor equal to 0 and solve. Okay. So moving on to the next technique, completing the square.